All right, so I'm going to go ahead and go over this question with you all. This is one of the questions that you're going to get on Delta Math. So is everybody paying attention to what I'm going to be doing up here? Yep. Okay. So it says a particle moves along the x-axis with the velocity given by. So they're giving you the velocity function. They're asking you to find basically the position function. So do you remember about position function, velocity, and acceleration? Yes. That whole chapter we did? So position function, we know that velocity is the derivative of the position function, correct? Yes. So if we're trying to find the position function, we're going to have to take the antiderivative of the velocity function. Now what's weird about Delta Math, and this is why I wanted to address it, they always use x of t as their position function, which is just bizarre because you're used to using x as your independent variable. So that's why I wanted to address it with you all, so you know that the change in variable. So we're going to take the antiderivative. So this is going to become t cubed because it goes up, and then we're going to divide 6 by 3, which is going to be 2. Plus, this is going to go up 1, so it's going to be t squared, and it's going to be divided by 2, so it's going to be 3. And then, of course, I have to put in the plus c. Now, when they give us this information here, they said the particle position and time. This right here, x is like your y, because this is basically your y. So this is going to be 1 equals, and then you're going to plug in 2 for t. Just like that. And now you have enough information to solve for c. Exactly. So it's going to be 1 equals 16 plus 12 plus c. So that's 1 equals 28 plus c. So c equals negative 27, right? So now that we know what c is, we have the complete position function. So earlier we were missing what the constant was, but now we have it. But you're going to notice that's not what the question's asking for. The question wants to know the position of the particle at time 3. So what am I now going to do with my new position function?
Plug in 3 for t.
Plug in 3 for t. That's a 3. So this comes out to be 54 plus 27 minus 27, which is 54. Yep, exactly. So the position is 54 at time 3. So see how it's very similar to the ones we did yesterday, but you just probably didn't realize it up until you'd seen it. So you're going to have 2 questions that are just like this with different numbers and different equations. Make sure, I recommend that you go and look at the Delta Math page if you want to do it now, or you can do it later. I put a breakdown of what to expect on the quiz, so there's no surprises there.
And that's tomorrow.
Yes, it is.